What's up, everybody? Sparewood again here from Sleepless Nights with another episode on Space Engineers Programming 101. Today we're going to be starting a new script. I debated quite a bit over what script to use, and I have come to the conclusion of a retractable solar panel array. There was a couple other things I debated, the other one being a combination lock that I thought would be kind of fun. The only problem with the combination lock is basically the only thing I can think of to toggle what buttons you're pressing are lights. So you would either have to have a lot of lights that are, or not a lot, but like a, I don't know, 3x3 or a 4x4 grid that are either out of the way or in some convenient means of doing things. There are a couple options that I'm exploring, particularly global variables. So, for example, but see, that's the other problem, is there's no way to affect the global variable without, there's no way to catch when a button is pressed. We had that problem with the airlock in the doors. So that's the only issue, really, is you need something that the button can toggle on and off. So that when the programming block runs one every cycle, like we have this one set up to do, which is run and then start, or you can do, I actually didn't think about it, you can actually set this up, instead of start, you can actually have it do, crap, remove that, trigger now, instead of starting. So you can just have it run, trigger, run, trigger, run, trigger. It ends up being about a second anyway, but it does kind of create a loop. But in between there, if you press a button on a button panel, there has to be something that basically is set to store. So that I press it, it stores that you pressed that button, and then when the program runs, it checks whatever is stored. Lights are the cheapest. I actually checked, because I was like, what about these control panels, or blah, blah, blah. Interior lights on a large ship are one construction component. Like, you can't beat it. Like, they're just the cheapest way to go. They do require power and stuff, though, but pretty much anything that can be toggled. I also found the Space Engineers updated recently and has this nifty little show hidden block thing, so I used it to clear up the clutter. Actually, I don't need that there. Yeah, that should work. But really anything. You can use cargo crates. Okay, maybe not. Anything that can be toggled on and off, pretty much. There are other ways of doing things as well. I'm still looking into maybe using a screen or something to store information, but again, with something as simple as a button panel, it's hard to store information in something like that to edit things, because, well, briefly, I know I'm talking about stuff that really has no explanation on the script that we're going to work on, but bear with me for a second. See, if I add LCD, it's just toggle off, increase... Increase font size. Anyways, so yeah, I'm looking into some other things. That actually might be a viable option. But for now, I know we can do something like this, and it's more useful, really. The locking mechanism is cool, but this is definitely more useful of it being able to add this to your ship and then just, like, push a button and it will just adjust the array. Would be cool. So there's a little bit of setup. I'm trying to make this code a bit more complicated, so that the code does more of the work, and you can basically just put a programming block, timer block to always check it. Well, actually, you don't even need that, but at the moment, at the current stage. The only stipulation I've found so far is it has to be up a block so that the rotor can stick out, right? This allows you to do... This may confuse some people, but I'm going to try and explain it as best that I can. If you're not familiar with working in three-dimensional space, this might cause issues. But basically, This rotor is called rotor Y, or solar rotor Y, I think. Because you might think, well, it's facing left and right, so it should be the X. But it's rotating along the... well... no, actually, I take that back. This is rotor X. My bad. Derp-to-der. You can see that because rotor Y is off of the piston, rotor X is attached to it. So, well, that we can show it on HUD. Actually, for now, while we're doing this, I'm just going to turn all of these on show on HUD. That way we can clearly see what's going on. We don't need the piston, it's very obvious. But so it's rotating along the X-axis because the X-axis goes this way. And once this flips up, this one, if you're up like this, would rotate along the Y-axis, which goes up and down. I thought about actually adding a Z to where like you could fold the solar panels up, but it just started getting to be very large. It wasn't able to stay very complex. The nice part about this is you can actually add to it a bit. I thought anyway. Maybe it won't let you add to the rotor. Oh, the rotor's in the way. I think you can go this way though. Yeah, so you can keep going and make a large solar array if you want to and put... I like to actually put batteries in here, but for the purpose of this tutorial thing, I'm just using default blocks. But you could put batteries in there for charging. I'm a fan of that. So this way you could create a bay that's this wide, and you can even have a dome that goes up over top of it, and the dome could open, this could come out and adjust, so on and so forth. So, now, on to the matter of hand. At hand. Of hand? That's weird. So, my screen here is set up to display some of the data. The rotor X, rotor Y, and piston and S panel is all the detailed info. I was surprised to see that was all the detailed info it gave, but that's the detailed info. And then we have... I don't know why it says single. That's not really a name, but anyways. We've got different variables that are... not really variables, but... oh, that's convenient. That is the last one. Values, I guess, is probably a better statement of torque, braking torque, velocity, lower limit, upper limit displacement, velocity, upper limit, and lower limit is for the piston. So this is rotor, this is piston. Solar panels don't have any. We're going to have to use the max output to basically determine whether or not it's fully functional yet. Now, at the moment, this is going to be a multi-part script, just FYI. I have not worked out all the logistics enough to do this all in one episode. So this is going to be a multi-episode. If that, you know, is frustrating, I apologize for that. But there was really no way I could get around it because I hadn't planned it well enough, and I really needed to get the episode done. So I didn't have the whole script ironed out in my head yet. So we're primarily going to work on the editing the rotors and the pistons and stuff if we get to it. We're going to leave the solar panels and determining direction part for later, unless we just do really well. Now, it's important to note 0 degrees is right there for the X rotor, and 0 degrees is right there for the Y rotor. That would be important for if you wanted to just place the rotors and run the script and have it work. However I get these rotors to move, it would be basically relative to them starting off in this position. So keep that in mind. The other thing we're going to look at is, like I said, I want to make this script as user-friendly as possible so you can literally place a block, build it like that, add as many solar panels as you want, and then it just works when you tell it to run. I don't want you to have to go through and edit the angles, the limits, all that kind of stuff. We're going to do that here. Now, I have one line added to this script, so let me briefly go over what's going on here. Some of this I've got commented incorrectly and stuff that we're going to fix this later. I had it set up differently. And some of this is going to go away. So we have text panel for display. This isn't really necessary. We'll probably remove it at the end of the script. This is just a reference for me. Now this is important. For some reason, they're called rotors in the main game, like when you look in the inventory. But in the program, it's motor stator. There's 3 different kinds of motor variables. There's a motor base. I believe there's a motor head or part or something to that effect, and then there's the motor stator. This is the one that we want. What those other 2 do, I'm not sure if it's just under the hood things that the programmers use, but they really don't do anything yet, or at all. For the programmable block, that may very well be true because they are listed as parents. We have the piston base class, which is what we define the piston as, and again I've set these up by name: solar rotor X, solar rotor Y, solar piston, and solar panel. The solar panel, we are going to need at least one of them. Whether or not we actually use all the solar panels or just use the one to determine whether or not it's optimal, but we are going to need a solar panel so that we can check the power so that we know what the optimal direction is. This is probably going to go away. This is a way to isolate these things here, the properties of a block. Oops, hold on. Not of type double, correct type is single. Okay, hold on. We'll get to that in a minute. That's something I was experimenting with that kind of broke. Alright, so we list iTerminal properties and named it props and made a new list. And then we have a string for the property string. This was debugging. You wouldn't need all of this, but it basically checked to make sure that it actually grabbed hold of the right rotors. And then get properties is the function to fill this list, and we filled props list. Then we looped through and added string. I've added type name and then added the ID. Now what I'm finding here, and if you'll remember that error we just got, the ID is actually the name that you could use to edit. The type, or the name, so we have ID is actually what it is. The name, or type name, is actually the kind of variable it is, which is really kind of odd, to be honest. I'm not entirely sure why it was done that way. So props I type name gives us single, but the props I ID gives us, you know, braking, torque, velocity, etc. Kind of weird. And then you can use clear if you want. So you could actually do props clear here if you wanted to, and then repopulate the list later. I just, for reasons, partially because I knew this wasn't going to stay here, cleared the list by reinstantiating it. Then I added an else that would add rotor x equals null if this wasn't true, and so it equals null. Same thing with pistons, same thing with solar panel. I was just trying to get all the properties so I could see what I had to work with to edit things. And then I did string info, and then did rotor X, Y, piston, and S panel was all detailed info. And then spacing and all that. We wrote it to the screen, and then we get to this part. This is the part where I'm actually starting to tweak things. So all of this prior is probably going to go away once we know what we're doing. This was just a way to get information on the blocks. Okay, so first off, I disabled the rotors during setup. The reason is I found with rotors, pistons, all that stuff, it's better to set all the settings and then turn them on than to try and adjust velocities, braking, torque, all that stuff while it's trying to move. So we did apply action on, off, off to turn them both off. When we get to the piston, we'll do the same thing. Then I have rotor X set value instead of apply action because this is not an action, it's just a variable. So set value, and in little quote marks because you supply a string. We did braking torque, and then I wanted to go 33.6. I'm going to explain this in a second too. So you can see braking torque is one of the values of a rotor, but it says it's listed as a single, so that's why when we ran this code, did it not compile? Or maybe it wasn't run. Ah! Caught exception during execution. Property braking torque is not of type double. Correct type is single. Now this is interesting to me, because if we look at the rotors, braking torque says 0 Nm. Oh, maybe that's why. Braking strength of the rotor, how fast it will apply, applied when the rotor is turned off. I'm curious. We'll see that the rotors are off, so that part of the script worked. But what I'm wondering is, if I adjust this to be a partial... Okay. So, alright. Before we get into this, there's something I want to show, and this is very important. I set up the private text to have a lot of different information that I found. For rotors, lower limit and upper limit have a minimum of negative 360 degrees and a maximum of 360 degrees, or unlimited, which is the default. Rotor displacement can be set to negative 40 centimeters or a max of 20 centimeters. Velocity is negative 30 to positive 30 RPMs. These are all things that you can use so that you don't have to figure out where you're going, type of thing, as far as how far your code can make something go. Braking and torquing, this is what's interesting. It goes from 0 Nm, which I won't lie, I'm not familiar with. I think it's newtons per meter or something. I don't know. I don't remember what. It has to do with pressure or force or something like that, or friction. But I don't remember what these measurements are for, but this is what they are. 0 Nm up to 33.6 MNM. And then I had this little diagram. 1,000 is 1 KNM, and then 1,000 KNM is 1 MNM. MNM. Torque is the same way, so I believe it's friction or force. It's like newtons or something. And then you have like kilonewtons per meter and meganewton. I don't know. Don't take that as accurate, because it's not. I'm guessing as to what they are. Pistons have velocity that can go from -5 to +5 meters per second. Minimum distance is 0 to 10 meters. Maximum distance is the same. So these numbers should help you out a little bit if you're trying to work with rotors or pistons, know where your limits are. But you can see that we have 1,000 Nm to KNM all the way to MNM, but it goes to 33.6. So this is weird to me, that it's a single type and not a double, because in the code, or not in the code, in the settings, you can set it to have a point. So now that we've set it to a point, let's see if this actually reads the same way, as far as if it's going to give us an error or not. Okay, it is. And it's giving us a single breaking. Okay. Alright, so this gives me a theory that I want to try. Theoretically, 7.8 kilo or something and KNM would actually be 7,800. Alright, so what we're going to try is we have braking torque set here, so let's set this to... I'm trying to do math in my head. Let's see. It should be something along the lines... Well, for kicks and giggles, let's do 7,900. Okay? Now this, in theory, if it runs... Not of type integer 32, correct type is single. Okay. So I'm having problems adjusting this through the code. Truth be told, I'm not really sure if I can. Let's try an explicit cast and see if that will work. It may not. Okay. We got no errors. That's good. Now the moment of truth is... Aha! It's 7.9. Alright. There we go. So that's how we can set this. So if we do... Let's try 100,000. So 1,000 should be 1 KNM. If we do... Or is it a million? If we do 1,000,000... It should be 1 MNM. There we go. We are working. Alright, so we want to set this to 3, 3, 6. So it's 3,360,000 braking torque, or NM. Now if we run this, it should... Oh, it only goes to 3.4. That's weird. Okay, new plan. Let's try that. Which should be 3.6. Oh, I'm a dum-dum. Okay, math. Math is hard. So let's add another digit. So we need 33. So it should be then 33,600,000. I don't know why I thought 3,360,000 would work. Booyah! Okay, so we got the braking torque set up. So that's the easiest way to do that. Now you'll notice we can confirm this because Y's braking torque is 0. So let's set a new line. Tab over and we'll do rotor Y. Set value braking torque. And we'll cast it as a single, which is a very weird variable to use. And we'll set it like that. We'll run it. And the braking torque is maxed out. Cool. Cool beans. Alright, now we get to the tricky part. We've got the braking torque set up, which means once we turn the block off, it's not going to, like, freak out and keep spinning. It'll lock itself up. Now we have to determine where we want it to go. So, for example... Now, the one thing I don't know is it has this listed as the current angle is 360 degrees. I don't really know why it has that. Because it's sitting at 0, which technically I suppose is 360 if it's partially off by just a hair. Like if it's... because this over here is 315, so if it's just, like, you won't see it visibly, but if it's just a hair over to this side, it's 360. If it's just a hair over here, it'd be like 1. So that's important to know. We need to set it to a positive rotation, I think. This is the part with rotors where I'm really bad. I won't lie. And we're going to save it first. If you have any suggestions, if this doesn't end up working out, we're going to test with the X block first. But if you have any suggestions, and because this doesn't work out or something, we will... I have no problem accepting that. For now, we don't want to set an upper limit. I don't think, because that would cause an issue. Because we're already at the max limit, if we set an upper... Ah, there we go. Wait a minute. That might work. Huh. Alright, let's hold that there for a minute. So its current angle is 0. We want a lower limit of... technically, we shouldn't mind it rotating all the way over. Let's do 135. No. Yeah, because 90 would be straight up. 135 would be slightly out here like this. So let's set the upper limit to 135 on the X, and we'll set the lower limit to 0 once it's moved. Well, no, it's at 0 right now, so we should be able to get away with that. Let's test it. This is gonna... I'm gonna try and break stuff, to be honest. So, rotor X, set value, upper limit. These are all singles, so we're gonna cast them as such. And we'll do... what do we say, 135? And hopefully the degrees measure in that way. In the code, I mean. And that we won't have to do it differently for... because this is kind of weird, I won't lie. That's a weird way to do things, because you have to do math and stuff on it. And then we said 0 for the lower limit, I believe. Let's check this and run it and see if it breaks anything. Didn't break anything. Our current angle is 0, our lower limit is 0, our upper limit is 135. Cool. We can mess with the rotor displacement too, but I don't think we're really going to need it. Alright, now, next step. We want to set a positive velocity at the moment. We can tweak it as we need to. But just for setup, we want to set the positive velocity as a single to, let's do 1. I don't want it to go crazy fast. Alright. So velocity is set to 1 RPM. We can adjust this later, but for now I just want to test it and make sure everything works. And we have an upper limit and we have a lower limit. Alright? So that would work if you just placed a block down, make sure that the 0 degree is set and facing up. So, oh, and just for testing purposes, re-enable rotors. So for here, we won't do Ys at the moment. We'll do an apply action. On, off, on. And that should theoretically work. Alright, so we're moving. That's good. It is moving slow, but that's fine for us right now. And see, at the moment, we're getting, you know, it and then we lose it. So it would want to go back. You know, like, we're going to end up adjusting that kind of stuff later. And, alright, and it stops there. To me, I'm thinking if this is out of the top of a ship, right? Like, this is the top of your ship, that would be kind of the farthest you'd want it to go. Otherwise, you wouldn't want it to really go any further than that. That's my theory. You're seeing how to adjust it if you want to adjust it yourself, though. This is going to be tricky. I don't know if a single can do a negative number. To cast negative value, you must enclose it in parentheses. Okay. Float is a type, but isn't... okay. So, to do a negative, we have to put this in its own set of parentheses. Right here, like that. So, singles in its parentheses, the value is in its own set, and then if you're doing a negative, it has to be inside its own, and then it compiles. Now, if we run it, it should come back. And because we have a lower limit set, I'm hopeful that it'll stop where it's supposed to. This is always kind of tricky with me, because I've had terrible luck with rotors in the past, but I never was able to do them with this measure of control. I was always trying to just slide bar it and adjust it and things like that. So... oh, 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 oh. Where are you going, dude? See, like that, it goes a little further past... I don't know why I did that. That's weird. Unless the... unless the weight caused it to do that. But see, current angle is -6 with the lower limit at 0. I don't really know how that happens. Yeah, I don't know how that happens. So if you have advice on that kind of stuff, feel free to let me know. Of course, this is easily fixable, and we may do it with putting a landing gear under here. Is the landing gears 1 block tall? No, they're 2 blocks. So you'd have to sink it down in when you're building your solar panel array. Now for the Y. For the Y, we won't really need anything. Now wait a minute, current angle. Alright, I have an idea as well. Let's run this again. Okay, it didn't move, but we got our updated angle. Alright, so if we had a timer block running, kind of like constantly, we could check things. Now let's test that theory by saying... Let's put a line right here that says if... Oh, I'm going to have to splice up the detailed info. Okay, so we're looking for... If that's the detailed info, I'm looking for the colon. So let's try... I'm going to try this one time, and if it doesn't work, then I won't... I will do it off camera and figure it out, and then work with it. So let's do string RX angle, and then we'll do RX angle equals rotor, oops, no caps, rotor X dot detailed info. Now, what we'll do is say RX angle equals, I'm forgetting the context. I believe it's, I think you have to use a string. Substring. Or maybe this is all one thing, I think. RX angle index of like this. And then that, let's see if that even runs. Okay, that compiled. Interesting. Wasn't sure if that would work. And then we'll do display write public text RX angle. And let's add a new... Well... No, let's actually just add some spaces for now, so that it's easier to see on the screen and I won't have to do that. Alright, so there's that. Well, it was supposed to be easier. Where did it go? Alright, let me double check this and make sure I've got it right, and then we'll keep going. Okay. So, I finally figured out what I wanted to do with it. The biggest issue was that degree symbol. That little booger was kind of getting in the way. So, what I did, it's a little tricky, and I'll probably move this section of the code at some point, but, let's see. Oh, and then I'm going to put this down here with the rest of the display code. So we have the right show public text and then update visual. I forgot to put those two in there so that it was actually doing things. RX angle equals rotor X detailed info. RX angle equals angle substring at angle.index of the colon symbol plus 2. The reason I did that is because there's a blank space and then you get to the number or the negative, the minus symbol. So plus 2 gets it out to the actual number, so there's no blank space in between you. Well, actually, no, I take that back. It starts right here at the index of the colon. So it'd be colon, space, and then the negative number. So if you add 2, it skips the colon, it skips the space, and goes right to the number. Then it wouldn't let me do it in the same line for some reason, but then I did a second substring where you start at 0, so the beginning of the string that we just clipped, and then you put a comma here, and then you actually specify a length of how long you want the string to be. And what I did was it starts at the beginning and it ends at length minus 1. So length would have been the last character, which is the degree, minus 1 takes that degree symbol off. Right? I hope that makes sense. So now what I'm going to do is I'm going to add, let's see, how do I want to do this? Just for example, just to test and see if this works, we want to do if ooh, this is going to be interesting. Okay, no, I can use the angle. Alright, if Rx angle... Oh, wait, no. What I'm going to do is... Oh, let's try this. Let's try this. Is equal to 0. Then we want to set rotor velocity to 0. Let's see if that will work. Oh, and one other thing. For this to work, we want to set the speed back to a positive number, and we'll remove the brackets. Alright, now before I hit run, what I'd actually like to do is use the timer so it continues to check this. Now, one big problem is we're going to be turning it on and off. Let's just see if this works. Alright. That actually worked. That's set to 0. Oh, that's cool! So we have a buffer now. We can actually set it to go, if it doesn't go where we want it to, we can set the whole thing up. Now, the question I have is it still on or off? It's still set to on. Okay, that's good. I'm not sure why the timer block stopped, though. As it's set to run and trigger and run and trigger and run and trigger and run and trigger. So I'm not really sure why that stopped, but whatever. Alright, so yeah, that's how we're going to work with the pistons a bit, or not the pistons, the rotors and things like that. I'm probably going to move things into functions later, so they're easier to work with and things like that. So, let me know what you guys think in the comments. Let me know as far as suggestions that you may or may not want to see in the code structure as far collision much. As far as what kind of functionality you'd rather it have. Do we want to have a limit on the Y rotor, or can it spin all the way around? Do you want to have further rotation for the X? Do you want to, you know, like anything like that, just let me know, and I will try and see if we can incorporate it. So I think we're going to wrap things up here for this part. In the meantime, I hope you all enjoyed. If you did, leave a like, and I will see you all next time. Peace.